Hello everyone, I am Karan Mashru. Welcome to this video. In this video, we are going to look at the solution of the problem alien dictionary. First of all, let us start by understanding the question. What does question say? Given a shorted dictionary of an alien language having n words and k starting alphabets of standard dictionary, find the order of characters in the alien language. So basically, we are given n number of words which are shorted in order. Okay, so they are shorted lexicographically, but in some alien language. So it does not necessarily mean that A will come before B. Okay, we need to judge that depending upon the shorted order. So for example, in the shorted order, there are three words having one character B, A and C. So B is before A in that alien dictionary and A is before C. Okay, so it is an alien dictionary and the words are given in shorted order. Okay, and they are made up of k starting alphabets of standard dictionary. So basically they will be made of let's say lowercase English letters from small a to small z, and we need to tell the order of characters in the alien language. Okay, so what order does that shorted order of words define? Okay, many orders may be possible for a particular test case. Thus, you may return any valid order and the output will be 1 if the order of the string returned by the function is correct, else 0 denoting the incorrect string returned. Okay, so there may be multiple possible orders of the depending upon the given data. So we need to return any one order which is correct, and if the returned order is correct, the output will be 1, otherwise the output will be 0. Okay, so for example, if we look at this, then here it is BAA, ABCD, ABCA, CAB and CAD. So this is the shorted order of words. Okay, so this comes first in the dictionary, this comes second, this comes third, this comes fourth and this comes fifth. Okay, now if this is the order, see there are four words A, B, C and D, right? Now if this is the first word and this is the second word, can I say B comes before A in the alien dictionary? Because if A was smaller than B, then this should be here. But since first word is BAA and second one is ABCD, so B should be before A. Okay, also BAA is here and CAB is here, so B also comes before C. Also ABCA is here and CAB is here, so here A comes before C. So what we know, B comes before A and A comes before C. We do not have the idea of D. Okay, here the order of characters is BDAC. B comes before A and A comes before C. That is valid. There was nothing dependent on D. So D is here. Okay. Note that the words are shorted in the given language. BAA comes before ABCD. Therefore, B is before A in output. Similarly, we can find other orders. Okay, there may be multiple possible orders. So it might be possible that if there is no dependency on D, so D may come here, D may come here, D may come here and D may come here. Right. Similarly, here it is the second example. Okay, so here we have C, A and B. Now here C is before A, so she should be before A in the output also. Also, if we look at these two words, then AAA is before AAB. So A is before B in the alien dictionary. So C is before A and A is before B. So the output should be CAB. Okay. And the output is 1 if you return the correct order. Your task is to complete the function find order, which takes the string array dictionary, its size n and the integer k as input parameters and returns a string denoting the order of characters in the alien dictionary. The expected time complexity is n star modulus s plus k, where k is the number of characters, where mod s is denotes the maximum length among all possible strings and expected auxiliary space is big O of k, and the constraints are given here. K can maximum go up to 26 because in standard dictionary there are 26 different characters. So now in the input we are given n number of words and we are told that they are shorted in the ascending order of the dictionary in some alien dictionary, and based on that we need to tell the shorted order of the characters. Okay, the like which characters come before which in the given dictionary, right? So basically let us suppose that looking at the words, how we will do that, we will look further. Okay, but let us suppose after analyzing the words we came to the conclusion that B comes before C. So what I have done is, if one particular character comes before a particular character, I have marked a directed edge between those two characters. Okay, so if B comes before C in the dictionary, how we will decide that, we will look. But if B comes before C in the dictionary, so I have marked the edge from B to C. Okay, directed edge. Now if B comes before E, then I have marked a directed edge from B to E also. If C comes before E, so I have marked a directed edge from C to E. If there is a directed edge from C to D, it means that C comes before D. If there is a directed edge between Q and R, so it means Q must come before R, and there is no relation between these 4 characters and these 2 characters and this single character, right? There is no edge between any of the 4 characters and this character. There is no edge between any of these 4 characters and these 2 characters, and there is no edge between these 2 characters and this one character. So there is no relation between this and this and this and this and this and this. Now why it is important? Because in the question it was said that there can be multiple possible answers. In case there are multiple possible answers, return any one. Okay, so if Q comes before R and these 2 characters do not have any relation with Z, then if we just look at these 3, okay, if we look at, let's say there are 3 characters, then Q must come before R. Okay, Z has no relation with this, so Z can come here, Z can come here, and Z can also come here. Okay, all these 3 are correct if we look at only these 3 characters. Okay, all these 3 are correct. So now what is the advantage of doing this? So now we have kind of created a precedence graph, like which node comes before which. Now if I do topological sort of this graph, I'll get the correct order of the dictionary. What does topological sort mean? Topological sort means if B should come before C, then in the topologically sorted output B will come before C. Okay, so for directed acyclic graph we define topological sort. Okay, now why do we define for a directed acyclic graph? Because there should be direction. Like what does topological sort say? If there is a directed edge from A to B, then in the output of the topological sorted order, what does topological sorted output basically do? It visits all the nodes in a particular order such that if there is an edge between A to B, A should come before B in the output. Okay, and this must hold true for all the edges, all the relations between 2 nodes. Okay, so that is nothing but topologically sorted order. Okay, now why it is defined for directed acyclic graph? Because the edges should be directed, that is the definition. If there is a directed edge from A to B, A should come before B. So graph must be directed. Why it must be acyclic? Because if the graph is cyclic, then we cannot define the relation. How? Let's say there is a directed edge from A to B, from B to C, and from C to A. This means A should come before B in the output, topologically sorted output. B should come before C in the output, but C should also come before A. Now how is that possible? So that's why it is only defined for directed acyclic graph. So if this is my graph, then my output should be B should come first, because there is no input edge to that, it is not dependent on anyone. Now if B is visited, then C can come, right? Because C, what was preceding C? Only B, right? Now if B and C have been covered, then E can also come and D can also come, right? So both of them are correct. So let's take E first and then D first. Okay, now Q must come before R, so I can add Q. I can also add Z in between and I can say R. Okay, so B must come before C, it is maintained. B must come before E, it is maintained. C must come before D, it is maintained. C must come before E, that is also maintained. Q must come before R, that is also maintained, and Z is independent. Okay, so this is one of the correct topologically sorted order. Okay, Z can come at the end also. D and E can be interchanged. There can be multiple things, right? Also there is no relation between this and this, so Q can come anywhere in between this, but the Q should come before R, right? So there can be multiple possible answers. This is one of the possible answers. Now how will we get this graph? So basically we will get that graph by comparing strings. Now how do we compare which string is before which? Okay, so suppose for in the example you are given car, okay, or let's say cars, and you are given carpet. Okay, suppose this is given before this in the dictionary. Okay, so now what I can do is I can traverse the string from left to right, and the first point at which I get a mismatching character, if this is before this in the dictionary, it means S should be smaller than P. right? I am talking this in with respect to alien dictionary. Let's understand with respect to standard dictionary. Okay, so that will give you a better idea. Suppose I have two words A B C D and A B E A. Okay, and let's take D and A. Now if I ask you with respect to our standard dictionary, which word comes before which, like which is lexicographically smaller, so what will you do? You'll traverse the words from left to right and you'll mark the first mismatching character. Now this is the first mismatching character. Here we have C, here we have E. Here we have a smaller character in the first string. It means that this is lexicographically smaller than this. That is how we compare two words. We move from left to right, and at the first mismatching position, the string which is a smaller character is a lexicographically smaller, irrespective of the characters which are here. Here there were DD and here there was AA, but now that does not matter. Since we have got the first mismatching character and it is smaller in this is the lexicographically smaller character. So now we cannot define any relation here, okay, irrespective of that. Here it could have been ZZ, even that this was lexicographically smaller, right? So we only look at the first mismatching character. Okay, now if we look here, suppose this is given before this in our dictionary, okay, in the question. So we start moving from left to right and we see that S comes before P. Like this word is before this in the dictionary, so S must come before P in the alien dictionary. So what I'll do, I'll mark a directed edge from S to P. Now I cannot judge the further characters, like suppose there is Z here, I cannot judge any of the relation between Z and E or Z and T. Why? Because here, as I said, after the first mismatching character we cannot judge anything, right? So we only, between two strings, we only see the first mismatching character and mark a edge from the string which was before in the dictionary, mark an directed edge from that word to, from that character to the character in the word which was after in the dictionary. Okay, so from S to P I have marked a directed edge. If we do this in the graph, like if we do this for all the possible combination of string, then basically I'll get a graph something like this, right? The precedence graph of characters, like how I have got here S comes before P. Once I got this graph, I'll do a topological sort and I'll get the sorted order. Now this, if we want to do this, do we require to do this between every pair of strings? There are n number of strings. So the total possible number of ways of comparing two strings and marking such characters is NC2, that is n into n minus 1 by 2, but that will take a lot of time, right? Now you do not need to compare every pair of strings, you just need to compare every adjacent string and make such edges, okay? So now what I said that in order to construct such a graph of characters, such a precedence graph, we do not need to do comparisons between all NC2 pair of words, okay, and construct such type of directed edge between two characters. We can do that only between adjacent pair of words, okay, and even that we will get our correct answer. Now why will that work? So let us look at this example. So here we are given three different test cases. In each test case I have three different words or strings, okay. If you look carefully, the first and the second words are same in all the three characters, the third word is different, okay. So now let us try to create such precedence graph. Let us try to create for the first one. So here if I look at the first test case, if I compare the first and the second string, the second position is the mismatching character, okay. So C is before B, okay, because this is the sorted order in alien dictionary format. So if I traverse and find the first mismatching character, it is at second position, so I can say C must come before B in the alien dictionary, right? If I do it between second and third string, the first mismatching character is at position 3, that is P and A, so P must come before A, okay. Now what I said, we need to do this only between adjacent strings, so we have done that. Do I need to do it between all pair of strings? No. So here I do not need to do it between first and third pair of string. Why? You'll understand in a while. One thing to note here is, here the position at which the characters were mismatching between first and second string is 2 and here it is 3. Here the position at which the characters are mismatching between first and second string is also 2 and here between this and this is it is also. So here the position at which they are mismatching is also 2, right? Here the position at which the words are mismatching between the first and second string is 2 and here the position at which the characters are mismatching in second and third string is 1, right? Now, so there can be at max 3 cases if I keep the first 2 string constant. So the mismatching character between second and third string can be either after the position at which the character between first and second string was mismatching. Here the position was 2, so either it can be after that, or it can be equal to that, or it can be before that. The mismatching character, there can be 3 cases. Okay, now understand one thing. So I have tried and taken all the 3 cases. Okay, now I have compared the adjacent strings first and second and third, and I have got this graph. Now let us compare first and third. So here the mismatching position is second, that is B and C. So C must come before B, that is what they are trying to say. But since the mismatching position here is 2 and here it is 3, so here the second character will be same, because the mismatching position between second and third string is third position. So here the second character will be same. So if here it is C and B, here also it would be B. So C must come before B. That is already covered by this. Okay, so I do not need to do between first and third string. Take the second example. If we compare the first and second string, the first mismatching character is at second position. It says C must come before B. If we compare second and third string, it is also at second position. It says B must come before P. So B must come before P. Now, since the mismatching positions between both of them are second, if I compare the first and the third string, so there will be 2 cases. Either this and this would be same, okay, but here we have P, so it says that C must come before P. The mismatching position is second, so C must come before P. Now tell me, C must come before B, B must come before P. Is there any need to put an H from C to P that C must come before P? No, it is already said here, C comes before B and B must come before P, so C must come before P, so there is no requirement. If I look at the third case, so let us take here. So here also, if I compare the first and the second string, C must come before B. If I compare the second and third string, then D must come before P. So D must come before P. If I compare the first and the third string, then it also says that D must come before P, because here the mismatching position is greater than this. Okay, so the first, here the mismatching position is second, here the mismatching position is 1. It means that the first character of both these would be same. So here the directed edge will be between D and P, here also it would be same between D and P. So do I need to draw it again? No, it is already covered in this, right? So what I am trying to conclude is that you do not need, in order to make the directed or precedence graph of characters, you do not need to compare all pair of strings. There are n strings, you do not need to consider all strings, that is n C2 pairs. You just need to consider the adjacent pair strings, and if you draw a directed edge between the mismatching characters, you will get a precedence graph, something like this. Now you run a topological sort on this, you will get this one of the possible answers. Okay, so now let's see how topological sort we will run on this graph. So basically, how do we run topological graph? So basically, if you look at the graph clearly, so this is the precedence order, B must come before C, B must come before E, and so on. So can I say, for all the nodes which do not have an incoming edge towards them, I can say there is no precedence order before them. I can start adding them in my answer list, right? So what I will basically do is, I'll take a queue and I'll push all the nodes which do not have an incoming directed edge towards them. So there is no, they are not dependent on someone. Okay, we can call them. Okay, they can be added to our answer. So at which nodes there is no incoming edge? At B, Q, and Z. So in my queue, I will add B, Q, and Z. Okay. Now what I'll do, one by one I'll pop out the elements of the queue and I'll add them to my answer, because in the queue I only have the elements such that their preceding elements are already visited or already added in the answer. So I'll add them to my answer and I'll nullify the effect caused due to them. How? So let us see. And I'll repeat this process until Q is not empty. So I'll pop out B and I'll add that B to my answer. Now since B is added to my answer, I'll nullify the effect due to B. What does that mean? C and E were dependent on B. C said that B must come before me. E also said that B must come before me. Now since B has already occurred, I can nullify the effect of these two edges. Now C and E have one less incoming edge towards them. Originally B must come before C, but now since B has already occurred, I'll nullify the effect because of that. And whenever I nullify the effect because of one node, if I get a new node whose number of incoming edges, or the in order, number of incoming edges is basically the in order of a node in a directed graph, okay, or the in order of a node becomes 0, I'll add it to my queue, right? Because if the in order is 0, it means there are no incoming edges left. It means that all the nodes which must be visited before that have been visited. So I added B to my answer, and now I can see that there is no incoming edge to C. So I will add C to my queue, okay. Now I'll pop out Q and add it to my answer and nullify the effect due to Q. So I'll nullify this effect. Now the incoming edge to R is 0, so I can add R to my Q. That basically means that Q is added to my answer. Now I can also add R because R comes after Q, okay. So I have added R. Now I'll pop out Z. I'll add it to my answer. There is no effect of Z, so will not do anything. Now I'll pop out C. I'll add it to my answer and I'll nullify the effect due to C. So I'll cancel out the effect of these two edges. Now there are no incoming edges to E. There are no incoming edges to D. You can add D or E in any order in the queue because there is no relation between D and E. D can come before E and E can also come before E. There can be multiple topological shorts, okay. So let us add E and D, okay, because here incoming edges or the in order is 0. Now I'll pop out R, add it to my answer. There is no effect of R. I'll pop out E, add it to my answer. There is no effect of E. I'll pop out D and add it to my answer. There is no effect of D left. So this is one of the possible topological shorts, and this will basically give me the sorted order of the characters in the alien dictionary. So just to conclude, what we will do is we will compare the adjacent words in the list, adjacent pair of words, and for every mismatching character we'll mark a directed edge from the character in the first string to the character in the next string. This will basically give us a directed acyclic graph. Then we'll call a topological sort in it, topological sort on it, and the topologically sorted order will be one of the possible answers, okay. Now let's look at its actual implementation. So now if we talk about the actual implementation, so I have taken some variables I, j, m1, m2. I have taken one string answer which is basically empty initially, in which I'll store the sorted order of characters according to the alien dictionary. I have taken one vector adjacency, one counter array and in degree array. All of them are of size 26. Why? Because the number of distinct characters can at max be 26. So counter of 26 will denote how many times a particular character has occurred among all the strings. In degree will basically denote what is the in degree of a particular character, like how many directed edges are towards it, and in order to store the edges I need an adjacency list. So I have taken an adjacency list of size 26. First of all, I have made the counter array and in degree array as 0, okay. Why I have taken counter array? Because understand, if a particular character is not present in any of the words, then obviously its in degree will be 0, right? Because it is not present. Suppose I have two words AAA and AAB. There is no C, D, E, F and so on. So the in degree will be definitely 0. But for those characters who are independent, like how Z was independent in our example, right? There was no directed edge coming towards Z or going out of Z, okay. So that case also in degree will be 0. So to distinguish between them and to know whether a particular character is present in the given words, and then only we will consider it in topological sort. So if counter of I is 0, it means it is not present in any of the words. So there is no meaning adding it to our topologically sorted order. So then what I have done is I have traversed all the strings for I equals to 0 to n. M1 is the size of the ith string. I have traversed all the characters of M1 and added it to my counter. So counter of dictionary ij minus 97 plus plus. So ith word, jth character, and why minus 97? Because this is a character and it will return an ASCII value. So I have to do minus 97 in order to map it from 0 to 26, right? So basically, for counter of 26, basically counter of 0 will represent counter of small a, counter of 1 will basically represent count of small b, count of 2 will represent count of small c, and so on. count of 25 will represent count of small z in the given words. Okay, so that's why I have to do minus 97 in order to get the indexes between 0 and 25. Then what I have done is I have traversed all the words, and for every adjacent pair of words, so m1 is the size of the ith word and m2 is the size of ith plus 1th word. Now I'll find the first mismatching character between ith and I plus 1th word. So I have to traverse how much? I have to traverse from 0 to minimum of m1 and m2. If m1 is of length 5, if m2 is of length 7, then I need to travel till 5 only to find the mismatching character. So if dictionary ij, it means the jth character in the ith word is not equal to jth character in I plus 1th word, I have found the first mismatching character. So I'll draw a directed edge from year to year, because this is first in the dictionary and this is afterwards. This is that I plus 1th position and this is the sorted order. So adjacency list of dictionary ij minus 97, again to convert it from index 0 to 25 I have done minus 97 dot pushback dictionary I plus 1j minus 97. So let's suppose this word is let's say this word is D and this word is A. So a directed edge from D to A will be drawn, but as I said, 0 will be used to represent A, 1 will be used to represent B, 2 to represent C. So a directed edge between third node and 0 node would be made. Okay, so that is what basically this adjacency list is doing. And I'll mark in degree of dictionary I plus 1j minus 97 plus plus. Why? Because if there is a directed edge from 3 to 0, this node's in degree will increase by 1. So I'll do in degree of this plus plus and I'll immediately break it. Why? Because we can only compare the first mismatching character. We cannot judge the relation of the characters which are after the first mismatching character. Okay, so I'll immediately break it. So basically in the adjacency list, I'll get such edges and the graph will be formed. Now I need to make a topological sort on that graph. So I call the topological sort function. I'll pass the counting array, I'll pass the adjacency list, I'll pass the answer string, and I'll also pass the in degree array, and finally I'll return answer. This topological sort will store in the answer the sorted order of the characters according to the graph formed. Now let's look at this topological sort function. So if we look at the topological sort function, so first of all, as said, I have taken a queue, I have taken one variable I, and for all the characters starting from 0 to 26, if the counting of I is greater than 0, it means it is present in some of the words and in degree of I is 0. It means there is no incoming edge towards it, so that can be added in my queue, because if there is no incoming edge towards it, there is no dependency of that character on any other character. So I can add that to my queue and add it to my topological sort answer. Now you understand why we have taken this. Because among the words, let's say P character is not present only, then that's in degree of P will also be 0. But if counting of P is 0, it means we do not have to add it into topological sorted order. So only if counting of I is greater than 0 and in degree is 0, then I'll push it inside the queue. Now as I said during the process, while queue is empty, take the first element, pop it out, add it to the answer. So answer plus character of I plus 97, right? And because in the queue I have pushed the value from 0 to 25, right? So 0 basically, as I said, represents A, and up till 25 represents small z. So I need to convert it back. So that is add 97 and convert it into character format. Now for all the elements which are in the adjacency list of I need to nullify the effect of the edges starting from I to somewhere. So if from I to X there is an adjacency list, since I have added I to my answer, I need to nullify this effect. So for all the elements which are in the adjacency list of I, make in degree of X minus minus, and if in degree becomes 0, add it to the queue, and repeat this process until queue is not empty, and you will get a topologically sorted order in your answer variable, okay, in your answer. Also remember, I have passed my string as reference, okay, because I have declared it in the find order function. Okay, what would be the time complexity? See, in topological sort, basically we are visiting all the nodes once. So I can say k, that is the different number of nodes, okay, that is the different number of characters present in the string, okay. We also traverse the edges, right, but the edges will also be some multiple of k, because if there are 26 characters and if there are edges among themselves, the number of edges also I can say would be some multiple of k. So I am taking it as k only. Plus, in order to form the graph, I traversed the adjacent pair of strings and matched them, right? So basically that for loop was of size n, and I can say the maximum length string, that is the maximum loop I need to do, because between every pair of strings I traverse the complete strings and find the first mismatching character. So to give a upper bound, I made a total n for loops, and for every for loop I made a string, I traversed the string of length modulus s, okay, and modulus s is the maximum length string to give a upper bound, okay. So this would be the time complexity. If I look at the auxiliary space, then if I look at the auxiliary space, it would be big O of k, that is the number of distinct characters. Why? Because in the queue I will get the distinct characters, in my answer string I'll get the characters in topologically sorted order which are present in the words. Then I have taken one counter array, I have taken in degree array of size 26, which is basically nothing but the number of distinct characters. So this would be my auxiliary space, and this would be my time complexity. Now let's submit this code. So let's submit it. So we have solved this problem successfully. I hope you have understood the solution completely. Thank you.